All right, these are the triangle proportionality theorem notes. I'm a little late to post them, but here they are. So we're going to start with a warm-up to determine if these triangles are similar. And if they are, we're going to go ahead and complete the similarity statement. If they're not similar, we're just going to write NS for not similar. Okay, so to start off here, we kind of want to decide what are we testing. So looking at this first one, are we going to test side, 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 angle, side, or angle, angle? So you have to look at what you're provided. Well, I see each triangle has two sides, and I also see that they have this vertical angle that's congruent. So we're going to test side, angle, side. See how it's side, angle, side for that triangle, and side, angle, side for that triangle. So as long as our sides are proportional, we can say that, yeah, these triangles are similar by side, angle, side. So to determine if they're similar, we're going to label our triangles. So just focusing on, let's start with this bottom triangle, just focusing on that one, we have to label it small and large, our sides that were provided. And we go by the number. So 42 is smaller than 63. So that's our small side. That's our large side. And then up here, 24 is small, 36 is large. Okay, so I'm going to do small over small and large over large. And I have to start with the same triangle. So if I do 24 over 42, I have to come back and do 36 over 63. Okay, and I'm just going to put these in the calculator and see if they give me the same value. So let's see, 24 divided by 42, I get 0.5714. I'll just go out four numbers, so 0.5714. And then 36 divided by 63, it's giving me the exact same number. So we can say that yes, these are similar by side, angle, side. Just remember, if this was different by even just one value at the end, this were a 2 instead of a 1, these wouldn't be similar. So make sure they are exactly the same. So these are similar by side, angle, side. We include that squiggly. That means similar. If the squiggly were not there, that would mean congruent. And then we're going to complete our similarity statement. So triangle TSR, I like to trace it out. TSR, it goes by the small side and then the blank side. So up here, we got to come by the small side and then the blank side. So TKL, triangle TKL. So there's the first one. Okay, for number 2, we could actually test a couple different things. So we are provided a lot of information here, and hopefully you can see how we have the big triangle and then the smaller one inside of it. Also, they share angle Q by the reflexive property. Angle Q of the small triangle is the same as angle Q of the big triangle. Okay, so technically, as long as we can find this side, which we can because we're provided these pieces, we can try side, angle, side, right? And then side, angle, side, as long as we can find this big piece too. Or we can get every piece of each of the triangles. We can get all 3 pieces. So we could test side, side, side as well. But let's go ahead and figure out our missing pieces. Let's figure out this piece of the small triangle, and let's figure out this big piece of the large triangle. So this one, I know that this piece plus 64 is going to give me the whole length, which is 108. So to figure out that piece, we have to do 108 minus 64. And so if you plug that in your calculator, it's going to give us 44. So we know that piece is 44. Now let's figure out this piece of the big triangle. I know that piece is 57, that piece is 39. So obviously if I add them together, it's going to give me the whole side length. So that's going to be 96. Okay, so now I have all 3 sides of both triangles. So I'm going to test side, side, side. Because if side, side, side works, then by the same reasoning, side, angle, side would work the same way. Okay, so looking at this small triangle, I'm going to label my sides. So 39 is the small number, 44 is the medium number, 55 is the large number. Okay, now looking at the big triangle, 96 is our small side, 108 is medium, 132 is large. So I want to do small over small, medium over medium, large over large. And so I'll start with the bigger triangle on top. So I'll do 96 over 39. It doesn't matter, I could have done it the other way around. Equals medium over medium. So 108 over 44. And large over large, 132 over 55. All right, so we're going to plug these in our calculator, make sure we get the same value. So 96 divided by 39 gives us about 2.46. 108 over 44 gives us 2.45. And then I'll do the other one just to see anyway. But that gives us 2.4. So none of these are the same. Even if two of them were the same, they still wouldn't be similar. All three have to be the exact same ratio. So in this case, these are just not similar. I'm going to write NS for not similar. And since they're not similar, we don't have to complete the similarity statement. All right, so that's what we've been doing. But this is an introduction to triangle proportionality theorem. So this was the second half of the quiz. Okay, and so you can read this side over here. I think it's missing a word. There should be the word that. I didn't create this little diagram, but if a line that is parallel to a side of a triangle intersects the other two sides, then it divides those sides proportionally. So I'll explain what that means in simpler terms. So there's four main pieces I want you to see. This first piece right here, let's go ahead and label that with a lowercase a. Doesn't matter. I'll use lowercase a. I could pick any letter. This piece right here, it's our second piece. I'm going to label that with a lowercase b. This third piece right here, I'm going to label that with a c. And then this piece right here, I'm going to label with a D. So those are the four main pieces. We want to find those four pieces in order to test the triangle proportionality theorem. This is saying the same thing I'm about to say. I just think the way I'm doing it is easier. Here's what it says. A over B is equal to C over D. So you can kind of think of this parallel line as like your fraction bar. So it says A over B is equal to C over D. I'll write that out. A over B equals C over D. And that's only true if these lines are parallel. And that's what these little arrows are right here. That means parallel. This symbol right here means parallel. It says EF is parallel to BC. So as long as those lines are parallel, we know we can use the triangle proportionality theorem to find missing pieces and stuff like that. So there's also different proportions that would work. I like to stick with this one, but there are several other ones that would work. For example, B over A equals D over C works. You could even do A over C equals B over D. That works. Sometimes they don't work though. For example, if you did A over C equals D over B, does not work. Don't do that. Another one that does not work is A over D equals C over B. Does not work. So if you want to be absolutely safe, I would just stick with this one. But I do want you to know there are other ones that will work. So let's keep this in mind, and we're going to solve for this missing side right here, the question mark. I'm going to change it to an x because that is a more classic variable to solve for. Okay, so we're going to set up a proportion. So hopefully you can see how this figure is similar to this figure if I were to just kind of, turn it that way. So I'm going to say 10 over 6, I'll do it right here, 10 over 6 is equal to 25 over x. So hopefully you see how that proportion works, and there are many that would work the same way. Okay, and so to solve for x, we're going to have to cross multiply. So as we have 6 times 25, that gives us 150, and that's going to be equal to 10 times x, which is 10x. So now we have 150 equals 10x. Well, how do we solve for x? Right now it's being multiplied by the 10, so we have to do the opposite. We have to divide both sides by 10. These cancel. We're left with x by itself, and 150 divided by 10 gives us 15. So that missing piece is equal to 15. Okay, let's look at example 2. So again, we're trying to solve for that little question mark, but I'm going to call it x. I think it's just easier. Remember, we need all 4 pieces to work with. We don't know this piece right here right now, but we can figure it out pretty easily. If the whole thing is 18 and this piece is 6, well, 6 plus something is going to give us 18. So 18 minus 6 is 12. That has to be 12. So now we can set up a proportion. I could do x over 8 equals 12 over 6. That'll work. And there's other ones that would work as well. And again, to solve, I'm just going to cross multiply. So 8 times 12, I believe that's 96, is equal to x times 6, which is 6x. We'll divide both sides by 6, and that gives us x by itself. And then let's see, 96 divided by 6 gives us 16. So x equals 16. Okay, let's go ahead and look at 3. So we're trying to solve for that missing piece x. I'll set up my proportion. I could do x over 21 equals 16 over 12. And we're going to go ahead and cross multiply again. It doesn't matter what cross I start with. I could always do this one first. Doesn't matter. So x times 12 gives me 12x. Let's see, 21 times 16 gives me 336. And then we're going to have to divide both sides by 12. X is remaining over here. And let's see, 336 divided by 12 is going to give me 16. Okay. Example 4. Trying to solve for x. We are missing a piece, though. We're missing this piece right here. We can figure it out. Just doing 28 minus 16, which gives me 12, right? Because 12 plus 16 gives me 28, so we know that works. All right, so let's see a proportion. The pointy side's down here now. I'm going to do 20 over x and 16 over 12. But again, there are other ones that would work. So let's see, 20 over x and 16 over 12. And then to solve, we're going to go ahead and cross multiply. So 16 and x, it's going to give me 16x. 20 times 12, that's 240. Yep. And again, we're going to have to divide both sides by 16. That'll leave x by itself. And so our answer is 15. Okay. Let's move to the back. Okay, so now we're doing the same process, but you'll notice that we have these expressions as some of our pieces. But it's going to work the same way. We want to solve for x inside that expression. So I'm going to start by setting up a proportion. So I could do 8 over 4 and 10 over 2x minus 11. That'll work. So 8 over 4 equals 10 over 2x minus 11. Okay, and we're going to go ahead and cross multiply. And since we have an expression, we're going to have to put it in parentheses because I'll have to distribute that 8 to everything inside. So 8 times 2x minus 11, I'm going to write like this. 8 times 2x minus 11 equals 4 times 10, which is 40. All right, and I have to distribute the 8 to everything inside. So 8 times 2x is 16x minus 8 times 11, that's 88, equals 40. Well, now this is just a two-step equation. I need to add 88 to both sides. Those cancel, so I have 16x equals 128, and then I'll just divide both sides by 16. And so let's see, 128 divided by 16 gives me 8. So that's the process here. So we can try example 7. So we're going to start by setting up a proportion. So I can do 8 over 16 and 10 over 2x minus 6. And again, when we cross multiply, we need to make sure to put our expression in parentheses so that I can distribute that 8. We have 8 times 2x minus 6 equals 16 times 10, that's 160. Okay, so I got to distribute that 8 to everything inside the parentheses. So 8 times 2x is 16x. 8 times negative 6 is minus 48. And now we have a two-step equation. So I'm going to start by adding 48 to both sides. Those cancel. I'm left with 16x equals 208. I'll divide both sides by 16. Let's see, 208 divided by 16 gives us 13. Okay, and then the last thing I want to talk about is, what if we're provided all four sides? How can we verify that these segments are actually parallel? Notice they're not marked, so we don't know if they're parallel right now. But if our proportion works, then that means, yeah, they have to be parallel. So let's go ahead and just test a proportion. So I can do 42 over 21 equals 30 over 15. And so we could either just put these separately in our calculator and see if we get the same ratio, or you could even cross multiply and see if you get the same values on each side of the equal sign. I'm just going to divide because I noticed 42 divided by 21, that's easy, that's just 2. And 30 divided by 15, that's easy as well, that's 2. So yeah, these are in fact parallel. This line is parallel to this line. If you want to write it out in some geometric notation, you could say segment KL is parallel to segment MN. You might see something like that. Okay. And then for this last one, we are missing some pieces. And it's not to say that you couldn't do a different proportion to verify this works, but I'm just going to stick with what we've been doing, so we kind of have one set way to do it. So to find this piece, well, if the whole thing is 9 and that's 2.7, 9 minus 2.7 gives me 6.3 for this piece. And then same thing over here, 10 minus 3 gives me 7. So now I have all of my pieces. I could do 6.3 over 2.7, and we want that to equal 7 over 3. So if you divide these, I think you get 2.3 repeating here and 2.3 repeating here. So we say, yeah, these are parallel. This line is parallel to this line. Doesn't matter where my arrows are pointing, by the way. And so if we want to use geometric notation, we can say segment MN is parallel to segment OR.